welcome Mr. Satish Babu, who is the chair at ICANN, which we discussed yesterday is the International Cooperation for Assigned Names and Numbers. And he's the chair at ICANN's APRALO, which is the Asian, Australian, and Pacific Islands Regional at-Large Organization. And he's also the chair at the Asia Pacific School of Internet Governance. Sir will be talking about emerging technologies and challenges, and sir is also on the advisory board of Youth IGF India. Sir, over to you.
Thank you very much, Hita. So I'd like to thank you for the opportunity to speak to this group. We've been observing the Youth IGF India right from its inception, and I'm happy to be here. So I think, can I share my screen? Or
yes,
do you have my presentation? Okay, I'll try to share my screen.
So we have your slides on backup.
Oh. Yeah. Okay, as a backup, right. So I'll be speaking about the emerging technologies and their some of the concerns that drive them or drive the civil society and all of us. Now, I'll speak for about 40 minutes, and the rest of the time we can keep apart for interaction. So keep your questions with you. We will open them up after about 40 minutes. So Ahida, please let me know on voice, not on chat.
Okay, sir. Okay, sir, sure.
Right, so we'll be looking at a bunch of technologies. These are by no means exhaustive. These are just some of the normal technologies that you hear of. Some of them are new, some of them are not really new. Like AI has been there since the 60s. But currently they have all come of age, and we are using all these technologies heavily. And thereby we have a bunch of concerns that these things generate. So let's quickly go through these technologies. So computing, we can say that the mainstream computing that we do today was from the mid-20th century. It's been rapidly evolving. In the 70s and 80s, we had networking capabilities added to the basic computing core. And from the 80s, we have the global infrastructure of the internet and the combination of computers and the internet. These two were very powerful building blocks for the emergence of a bunch of new technologies in the last several decades. And when you look to the future, we find that our future is inextricably tied to computers, internet, and these emergent technologies. So we will look at some of these technologies very quickly. Now, AI is, the ability of a computer or a robot controlled by a computer to do tasks that are done by human beings, because it requires some level of intelligence and discernment, and that the machine is able to handle. That is when we talk about artificial intelligence. Machine learning is a subset of artificial intelligence, which to a great extent automates. Now, you can write code for artificial intelligence based on rules also, but writing rules is very tedious. We have to cover every edge case, every eventuality. So that's a very hard way to do AI. But machine learning makes it much easier because it automates its whole business. And deep learning further automates it. And in machine learning, you have to provide, there is a human intervention required. You have to say, okay, this is a car, this is not a car. But deep learning, even that is not required. It can automate considerably, what the subject matter of what we're trying to do, but it requires very large amounts of data. And data, therefore, becomes key. And we will see some of the implications of the need for data in future slides. So here you see that AI is a big circle and machine learning is a part of that. But data science, which we'll talk about shortly, is yet another area. And big data is something within data science, but it intersects with deep learning. And deep learning requires very large amounts of data in order to automate. And there are all kinds of implications of this. When you handle very large quantities of data, you're talking about an environmental impact. And we will talk about that as well. Now, what is data science? Data science is an interdisciplinary field that uses, basically statistics and different algorithms to extract knowledge and insights from noisy, structured and unstructured data and apply these knowledge and insights to actual, decisions. Data science was earlier called data mining. In the last 30 years, 30 years ago, it was called data mining. Today, it's all mixed with machine learning and it's called big data also. And it brings together statistics, data analysis, and informatics. Now, since the amount of data generated in the world has grown explosively, data science has become a very important branch of computer science today. There are a lot of jobs going in data science, and for job seekers also, data science is very important. Now, data is also a key for most of the big tech. Big tech would mean the likes of Google and Amazon, Facebook, and so on. And the data economy is a global digital ecosystem of information generated digitally as well as from non-digital sources. So eventually, even information from non-digital sources, for example, retail, we have a lot of e-commerce, which is digital, but we also have a lot of brick and mortar stores that is non-digital. But eventually, even the non-digital data finds its way into the global digital ecosystem, where it gets used for deep learning or machine learning or whatever. Now, the previous speaker mentioned cyber physical systems. Now, I am kind of putting it all under the common label, IoT, IIoT, that's Industrial Internet of Things, autonomous vehicles, and cyber physical biological systems. This is a broad set of technologies that involve interactions between digital, analog, physical, and human components, all integrated together to function together as a single cohesive unit. In other words, these systems integrate algorithms with physical systems. And possibly, these days we're talking about gene editing, and we will see later something called precision medicine. So there is a huge amount of IT content in biological work also today. Now, this set of things also includes IoT, the conventional IoT, IIoT, that's industrial, like the factory floor automation, smart cities, smart grids, smart everything, smart car, smart home, smart office, smart classroom, and so on. So we hear of a number of smart things, and these smart things come from a combination of sensors, then backend, repositories of data, rules, and machine learning kind of core, which in turn can drive decisions and actually make things happen. For example, you can have a paddy field, which is the water levels or the fertilizer levels are monitored by sensors, and the sensors act when there is it triggers a certain, suppose there is low water. When the water is sensed, it is found low, then it can automatically actuate different pumps or whatever and ensure that the water is back to normal. These systems are controlled by a compute communicate core and are challenging because of various constraints, spatial temporal, because these are happening in real time. If you have a self-driving car, the car is on the road going at whatever speed, and it has got to respond in that real time. We cannot have, delayed. We can't have like you have when you go to YouTube and you see buffering. You don't see any video, but you see some circle going on, round and round. But you can't have that in a self-driving car. So there is a minimum guarantee of the response time. The need for dynamic responses, extreme networking needs, and the need for fault tolerance and autonomy. You can't, your computer crashes and you reboot it. But if your car crashes while you're moving at 70 miles an hour, you have a real problem. So these systems are very, very demanding. And you also see that, therefore to engineer these, there are a lot of complex, background work to be done. Now, we are also very familiar with robotics and automation. Robotics is design, creation, and use of robots. There are physical robots that substitute for human action. For example, there is a robot specially created for the elderly to alleviate their loneliness. Automation is largely the use of self-operating physical machines, and mostly in the context of an assembly line or a factory. So these technologies are transforming factories, homes, and hospitals, and even other places, also offices and so on. Now, the word automation sometimes is also used purely for software-based or pure software-based applications, like in test automation. When you're writing tests for testing a web application, and you want to automate because you make a small change, you want to run all the tests, so you automate them. Otherwise, it's very tedious for a human being to do this. Or something called robotics process automation, RPA. This also does not involve real robots. This is much of office work like filling forms. We can automate it, and that is what is RPA. The blockchain and digital currencies. Now, we are aware that Bitcoin in 2008, the white paper came out, and the code base was open sourced in 2009, and we had a community growing around it from that time onwards. I joined that community in 2013 when I bought some Bitcoin, and that is in March of 2013. And later on in December, I sold it. And I realized that there is a whole lot of surplus in that transaction. This is not to say that when you buy and sell Bitcoin, there's always a surplus. There's a lot of fluctuation of the value, the price of the Bitcoin. But what is interesting about Bitcoin is not the value per se, but the fact that One is that the identity of the person or group who invented Bitcoin is unknown despite extensive speculation. But the real achievement of Bitcoin is that it brings together computing, networking, and economics, or behavioral economics to be precise, to incentivize a community to create and use a secure and stable currency system, avoiding double spending. Now, this double spending is a key problem that any digital currency has to overcome. The reason is, any digital asset, suppose you take a picture or a song, an MP3 song, we can easily replicate it. We can make as many copies as you want, which is very unlike real world. If you have a chair, you cannot make a duplicate chair without a whole lot of, you have to buy the wood and paint and get a carpenter to make it. But a digital asset is not like that. A digital asset can be instantly replicated. But if you have a digital currency, a digital dollar or a Bitcoin, if you are able to freely replicate it, then what's the value of that? So the double spending is a core problem that had to be solved, and Bitcoin did resolve it. In the process, it created something called the blockchain, which is an immutable store, which is what it uses for avoiding this double spending, because it can check back and verify that this coin was not spent earlier. Now, what is the challenge really? What is the big accomplishment of the blockchain? The real challenge is that the blockchain is a piece of technology that allows for trustless computing, meaning you don't have to trust an entity. Suppose you have a regular database. The database has its administrator, and you have to trust that administrator that he or she does not inadvertently or maliciously change the data. And history has shown that you cannot trust any organization or individual just by forcing people to accept the trust. Even the biggest organizations have seen breach of databases, loss of data. But blockchain ensures that you don't have to trust anyone, any organization, or any person, because technologically this is secured by cryptography, and it is impossible mathematically to kind of change, and there are sound provable reasons for that. So the blockchain is a very interesting kind of a technological backing in the backstopping arrangement for the Bitcoin. But the Bitcoin has many issues also, because Bitcoin, later on we'll see the environmental impact of Bitcoin. But the Bitcoin's major problem is that the legal systems of countries, for example, India, find it very difficult to accept Bitcoin as a currency. First, it will undermine India's rupee, and the Reserve Bank of India does not want that. Secondly, it is controlled by some group outside the country. I mean, it's a global group, and we don't know who the group is, and the identity is not necessarily public. Some of them are secret people. I mean, we don't know; they're anonymous. So why should the country's government, agree to let it be used as legal tender? So India is just bringing a law after a long, time of dithering to block the transactions using Bitcoin, or at least make it illegal in India. But the cryptocurrencies, not just Bitcoin, but a huge number of Bitcoin, digital currencies which are in existence, have a number of features. So you have DeFi, for example, or NFTs, that is non-fungible tokens, or stable coins, which do not fluctuate in currency, the value as Bitcoin does. And because India's legal system does not permit Bitcoin to operate here, we are unable to access all these innovations in the cryptocurrency platform. So the Reserve Bank of India and several other central banks around the world are thinking of launching their own CBDCs, central bank digital currencies. And these are created by the central bank, in our case, Reserve Bank itself. And this is a huge step for financial inclusion. You might be confused as to why should a CBDC be different from Google Pay or Paytm or whatever. Now remember, all these Google Pays and Paytms are a thin layer over your bank account. But CBDCs don't even require a bank account. So it's just like cash in your pocket. So you can, in theory, it'll work off a smartphone wallet, but you can use it anywhere. You can, on the roadside, there's a tea shop and you have a tea and you pay in CBDC. So this is a completely different animal. And unfortunately, the RBI has not made it clear as to what their plans are. Precision medicine, the current medical system is based on one-size-fits-all assumption. Precision medicine brings together several technologies such as individual genomics, genomic sequencing, molecular biology, artificial intelligence, etc., to create sharply focused therapies. Precision medicine uses the panomic approach, analyzing the genome, proteome, transcriptome, microbiome, etc. Now, I'm not sure whether you have heard of all these terms. Give me a second, I have some noise happening here. Yeah, sorry for that. Yeah, so these are these are different protein systems in your body. Like microbiome is not even your body; it is a bunch of microflora and fauna in your body, on your body, etc. Which is, I mean, there's a huge amount of these microbes, or basically bacteria, but not just bacteria. And this constitutes the collective, the union of all this constitutes the microbiome of an individual. And this is individually different. For every individual is different. Therefore, precision medicine looks at your very specific aspects of an individual person. And it is actually heavily dependent on computing tools, because if you take a genome, it is running into terabytes of data. And if you want to process the data, it is really a huge amount of work. But this can help in predicting medical conditions. It can tell you whether you're going to get diabetes when you are 50 years old. And can preempt disease progression, customize prevention strategies, and reduce the current trial and error approach. We now move on to some of the cross-cutting concerns. And this is where the governance of these emerging technologies become important. Now, we are all very concerned about the environmental impact of everything today. We just had the COP26 happening in Glasgow a couple of weeks back, and we were looking at the outcomes, and the outcomes are not really good. We are in a very, very dangerous situation. We are not able to contain the warming to 2 degrees. It will probably go to 2.5 or even more. So there is a problem that we're facing. So we should be aware of the fact that every technology involves an impact environmentally. Every Google search, every email, every good morning in WhatsApp has an environmental impact. When India wakes up and says good morning on WhatsApp, the whole internet chokes, because India is so huge. And I find it a completely pointless exercise, wishing good morning on WhatsApp. It's the most useless thing ever. It consumes, it has an environmental footprint. So we should not be doing this, and we should be more guarded. We find that some of us do. We are concerned about the environment, but we are promiscuous when it comes to the use of technology. Now that's the contradiction, and we have to look at Now, if you look at Bitcoin, it uses enormous amount of technology. While I'm an admirer of the technology behind Bitcoin, I have major issues with the fact that it uses excessive amounts of energy. But many other newer currencies, there is no problem. They have actually scaled down on the use of, by switching from proof of work to proof of stake, proof of delegated stake, and different other consensus algorithms. Now we have to look at green algorithms, which use less energy. Currently, we have many algorithms with us, but we have to look at those that are computationally not intense and use too much of energy. Also, when you have very concentrated uses of computing, for example, a cloud data center, we must use clean energy to drive that. So if you're setting up a cloud data center, you might want to think of a solar kind of a system around it in the same area, where you can generate the at least a 50% or 60% of the total energy required. However, given that we do not have visibility into the energy strategy of most tech companies, it is not yet possible to pin them down or make them more accountable. If you have a data center, we can't look into that company's data center and decide whether they're efficient or not. There's no such system in place. And it's dangerous that we need to now have such things. Secondly, we have ethics. Now, algorithms that drive many of these complex technologies do not encode ethics, but are directed at business goals. So Facebook's algorithm is to make more profits. So how do they make more profits? By ensuring that the user remains on Facebook or YouTube as long as possible. So every day you push him to stay longer. Or so how do you push him or her to stay longer on Facebook? Show them the most controversial content. So you get very excited and you respond. Sometimes outright fake news. And by doing that, you spend more time on Facebook, which is exactly what they want. And then they'll show you the ads, and then they'll take your data. So there's no incentive for the algorithm to be more guarded in its approach. Then the last speaker also pointed out the hidden biases. Now, people say that algorithms don't have bias, but data has bias. There is a certain number of truth in it, because algorithms start out clean. And then you put data into it, and depending on how the data is structured, where is it from, the algorithms kind of become either neutral or they have biases. And because of the fact that these are not rules, like in machine learning or deep learning, there are no rules. These are actually some numbers in a complex neural network. It's very hard to remove a bias from the system. Earlier, a single racist bank manager's action remained only within his branch. But if the bank software has a bias, it permeates the entire bank. So the entire complex of all the branches in the country get impacted by the software. So this is a danger of hidden bias and ethics. So how do you handle this? There have been various methodologies. IEEE has a very interesting program where they ethically align design, they call it. Even from the design phase, we have to think of ethics in the system. Cybersecurity, reliability, robustness. Now, as systems become more complex, networked, and algorithmic, the possibility of errors also increase. In addition, there could be backdoors left in the system for testing or for even geopolitical reasons, which could be abused. The COVID-19 pandemic has seen a sharp rise in cybercrimes, DNS abuse, ransomware, phishing, scams, misinformation, etc. Most modern computers and mobile phones use hundreds of programs, libraries, and utilities. And recent trends indicate the trend of increasing supply chain attacks, with even state actors getting involved. So these are very troubling times, because even countries are involved in some of these attacks. A supply chain attack is when you use a library, and that library uses another library, and that library is maintained by a group of people who are very open and trusting. And somebody attacks that library and adds a Trojan there in that, and that then gets carried on to the final product, which is in a totally different scale, totally different place, and that's a supply chain attack. Now, as we talk about complex systems, you have to understand from the failures that have happened in history. Today's systems are very complex, of hardware, software, and you have sensors and actuators. And if you take your mobile phone, for example, it's not just a computer. It is much more sophisticated than a laptop computer. It's a whole bunch of things combined together, which is very unusual, and in a very small form factor also. Now, the problem with such complex systems is that they are very difficult to test. Because, for example, a self-driving car may have an eventuality on the road which could not be predicted by the designers. So in the past, there have been many, many cases. I'm just quoting 3 here that have resulted in death. Therac 25 was a chemotherapy, not chemotherapy. And for cancer, you use radiation therapy. And this is a machine that was developed by a Canadian company for exposing radioactive content to a patient. Now, what happened was that there were 2 other models before which worked perfectly well. So the Therac 25 model, they moved into more software control. And then they found that patients were randomly dying when this machine was used. They didn't suspect the machine. They thought something was wrong with the patients. But later they found that all these patients who died were treated on this particular machine. And then they found that randomly, because of the way that thing was not tested, it overdoses patients, and then they die. The London ambulance system was another one, which is a combination of human factors and coding. They switched from a manual system in London of ambulance dispatch to an automated system. And the automated system was engineered by a group of people or a company that had very little experience in designing such complex systems. And that went into such a big problem that many people died. The health secretary resigned. There were all kinds of chaos. And the most recent is, which is currently not even closed, is Boeing 737 MAX. This is a very clearly an ethical problem also on the side of Boeing. The 737 MAX was actually a brand new airliner 737 extension of the very, very old, very stable 737. They wanted to make it longer and add more people. So they made it longer, but they couldn't kind of change some of the other factors to match that change. And instead, they put in a software, kind of a Band-Aid. And that Band-Aid was not properly communicated to the pilots. And 2 airliners were lost. And all the people are killed in this. So Boeing eventually had to pay more than $2 billion as damage. But then even now, not all countries have allowed 737 MAX to come back. So this is a very interesting example of a complex system which resulted in people's deaths. Now, why do these things happen? There are many groups involved, and there's no pinpointing of the failure responsibility. Like if you have an architect put up a skyscraper and it falls down, the architect is going to be legally liable. But how about software? Who's legally liable for software failures when it kills people? It's very unclear. There are bugs in the code, and you blame the computer's scapegoat, corporate policy and corporate greed also, and poor testing and difficult to replicate real life events. Next, we come to data. We mentioned that for machine learning, data is very important. And how do you govern data? Data is required in large volumes for new technologies to work. Many large companies provide free end user services, like Gmail, for example. You don't have to pay for the email service, but in return for user data, which is extensively monetized both internally and externally. Tough rules such as the GDPR in Europe are definitely required to get companies to protect the privacy of user data. A number of unscrupulous practices by big tech have been reported. For instance, data harvesting by Facebook, not just from Facebook itself, but even third-party websites. Facebook also has been taking data from the accelerometer. You'll be surprised to know that a whole bunch of behaviors can be predicted from the accelerometer data. For example, it can tell you whether you're drunk or not. How does it do that? It senses from the movement of the phone. And there's a very interesting paper that says it lists about 30 or 35 different things that can be sensed from the accelerometer. It is really surprising. And sometimes you can't even turn it off. There is no guarantee that the program is not still using that data. Similarly, Google and location data. Even if you switch it off, even if you remove the SIM, Google will still collect location data. So this is, and when you connect back to the network, it'll put all the data into the cloud, into their cloud. Now, laws are becoming more demanding, but tech companies are still one step ahead. Accountability, transparency, and legal aspects. Usually, legislation always is a step behind technology, because technology is changing very fast. Now, how do you make these tech companies accountable? Now, one is, of course, to have legislation, but that is always behind. So if the legislation is behind the technology, then what do you do? So one way would be to kind of ensure a degree of accountability for companies to declare public voluntary commitments. Now, in ICANN, where we talk about domain names, there are domain registries. Like, for example, if you take .asia, that's a domain registry, and .asia organization runs the registry. So these registries are encouraged to provide what is called as voluntary commitments. So they will public voluntary commitment. They are making a public statement saying we will do this. So .asia might say we will support community projects in the region, in Asia. And then the people can then hold them to it. So such kind of a public voluntary commitment would be useful if companies put them out publicly, and users use them to judge between companies. Social audits of algorithms for energy efficiency, bias, privacy protection, monetization strategy could also be considered. Social media platforms acting as judge, jury, and executioner should stop, particularly when the democratic system has very little oversight over them. So what is the oversight that anybody has over Facebook or Google? Very little. Okay, you can go to the court, but everything is very vague. And it's Facebook decides which content is authorized, which is not fake news, which is fake news, etc. This is a very difficult kind of a situation. And finally, we also need standards and best practices. We are users of many of these emerging technologies, and we are surrounded by them at home, school, or office. We wear them as watches and fitness bands, and some of us may even have them inside of us. As we go forward into the future, yes, we'll have more and more of us will have devices inside us. In order for safety, security, and wellness, it's important to have standards that everybody have to comply with, and best practices that will help level the playing field. Open standards, open source software. Now, what is good with open source software? The source code is free, which means we can inspect the source code. We can audit the source code, but we can't audit a proprietary code. For example, Windows source code, we can't audit. Linux source code, which I'm using Linux right now, you can actually audit. Anybody who wants to see the Linux source code, it's publicly available. And where possible, open data would be of use as we look to the future. My last slide. The pace of emergence of new technology is accelerating, and the world is set to see numerous new gadgets and social media and many of the technological artifacts. And some of these will be deployed in public places, for example, cameras. And obviously, they have negative connotations also, because that amounts to surveillance. And there are many states which are actually actively doing this surveillance. While these technologies have very important uses, they can also be misused by the state, by various threat actors, or by the tech companies themselves. As technology and policy/legislation co-evolves, additional safeguards may be necessary to ensure that the rights of all stakeholders are preserved. The governance of emerging tech is therefore an important aspect of our common connected future. Thank you very much, and I'll stop here. And if there are any questions, I'll be happy to kind of take them on.
Thank you, sir. So we still have 15 minutes to go for the session. So all your questions are more than welcome. Please put them in the chat, or if you're interested to, if you're okay with, unmuting yourself and asking, please raise your hand. Okay, we have a question already from Divya Tiwari. Please go ahead, Divya.
Good morning, sir. Sir, I just wanted you to enlighten us on emo toys, a new concept that is actually coming from UK and USA in India itself, and is a blunt infringement of the right to privacy and right to life of children too. The emotional intelligence toys, sir.
Right. Thanks very much. So I have no clue what these are, but I can guess that there have been many cases where both the big tech like Facebook, for example, they've been pushing for Facebook for children. Children are a kind of a focus group because of the fact that, one, the parents are able to spend money on them. Second, they are the generation of tomorrow. So there are many efforts to kind of reach out to children and get them to use a product. It could be a toy, it could be disguised as a toy, or it could be social media, like Instagram and so on. So children, these big companies are definitely trying to target children. Now, there have been at least one case where there was a tablet aimed at children, which was produced by a Hong Kong company, which was hacked at the back end. Now, this tablet could take pictures of children also and record audio also. And these are in the home context. And you can imagine what would happen if the back end was hacked and all the pictures of children at home, they were leaked. And of course, that went on to kind of become a big case. And that also resulted in more fines for the company and new laws. But the point is, I can imagine that, I don't know exactly what this is, but there will be a natural tendency for technology to be provided to children so that they can be kind of brought on board earlier and made a kind of captive of these technologies, which is happening to many of the young people today. Partly because of also the fact that people are forced to use the mobile phones for classroom sessions now because of COVID. I'm sure that also will have its impact for the future.
Thank you, sir. We have a hand from Divin. Please go ahead, Divin.
Good morning, sir. So we touched very briefly on blockchain and focused on Bitcoin. So I'd like to explore that domain a little bit. And since in blockchain itself, we have come a long way from decentralized finance to NFTs and to now metaverse, in light of which even Facebook has rebranded itself as Meta. So with all the actions it's taking with VR and Oculus, how much of life do you think can be packaged into pixels?
Thank you for the question. So this has been another technology that I did not mention in my list of technologies, the XR, that is AR, VR. XR is anything R, that is, reality. There are various, like I said, Facebook strategy is to get the individual to spend even more time on the platform. Now, you should see this as an attempt to further that engagement with the platform. So far you could only type things, but now you can, move, you can touch, you can turn your head around, and you can be in that immersive reality. And that may be even more addictive. So that makes Facebook even happier. I would have been okay with it had they not had any advertisements inside that. But even if they don't have advertisements, they are still looking at what you are doing in that space. They are examining every microsecond that you spend there. What are you doing? And that data is being taken, and that will be attributed to you. And that will be kind of sold later to people who are looking at what are you interested in. So I don't use Facebook much. I have an account, but I don't post anything. I haven't posted in a long time. I am basically not very happy to kind of use Facebook because they are so invasively aggressive and they take your data. And but of course, it's not just Facebook alone. All of them do that. But Facebook is particularly risky, especially if you post pictures without restraint. So on Facebook, people can make out where you are. Are you at home or are you on holiday? And there have been so many cases where people have been exploited because of Facebook. So I'm not surprised at Meta. I'm not surprised that they're using Oculus and other kind of immersive reality technologies, because their objective is to kind of keep you more and more inside the Facebook platform. They don't want you to even leave the Facebook platform. And in relation to cryptocurrencies, Facebook's original project is called Libra, which is a cryptocurrency. Right now it's called Duo or something like that. So that was a parallel digital currency floated by Facebook that would instantly enable anybody with a Facebook app, WhatsApp, Instagram, or any of the family of Facebook apps to instantly start moving money, just like your Google Pay or whatever. So when that was announced, and it's not just Facebook, it's a consortium of companies, many of the states, I mean, the central banks were very worried. And in fact, the CBDC's arrival is primarily because of the push from Facebook's threat that they're going to come. Some of the African countries welcomed it, saying that, you know, you don't care, you come. But many other central banks said, no way. Even currently, it is still undergoing regulatory scrutiny in the US and in Europe, and it's not going to be easy for them to really launch it. But they did have that plan, and that has actually impacted the plans of central banks of different countries.
Thank you, sir. We'll next have Parthajit. Please go ahead, Parthajit.
Good morning. Sir, my question to you is this, that with the passage of time, we are being more and more dependent on technology. And in fact, if we do not adopt technology, then our life, the hardships increase. For example, adoption of UPI or social instant messaging apps. But there is a significant section of the society which are unable to cope up with these with the new technology. As a result, they fall victims to a lot of crime, be it fake news, be it scams or something like that. So is there a solution to this, especially the older generation? My mother still forwards me a lot of WhatsApp fake news. No matter how much I tell her, she out of concern sends it. But she's becoming a victim in one way. So do we have to simply wait for this generation to eventually die off, or do we have a real solution to this?
Yeah, thank you for the question. I think this is a tough one. The reason being, it is not just the older generation. Even people in the younger generations are being scammed, and they're falling for it also. Now, that scam may be a financial scam, it may be a romantic scam, it can be, there are a huge range of scams. While I agree that the relative proportion, now the young people over a bit of time automatically become very skeptical of anything. If you meet someone online, their age, their gender, nothing will be real. And they're all kind of inured, they're all kind of immune to it now. But the older generation is not like that. So secondly, the level of information, level of the current young people are born into digital technologies. But people of my generation even, they kind of came into by force. They were forced to kind of adopt some of these things, mobile phones and UPI or Google Pay or whatever. And the even older generation is really sometimes they find it difficult. But I can tell you that my dad, who's now 85, takes classes on WhatsApp. He's a musician, and he takes music classes on WhatsApp, and he started that during COVID, and he is able to do it very well. So it cuts both ways, but he also does not know many things about scams. So that's the only way out of that is education. Now we have to, there should be, maybe some groups for older people where they can check. Maybe the government can run such a help desk, or maybe some NGO can do it, or maybe the youth, some organization of youth can do such a thing, wherein anybody who has a doubt on what the hell is this could call up a help desk number and ask that question in their own language and get a kind of reply. But I would still say that I still underscore the point that even the younger generation, the current generation of say 35 to 50, they all should be very careful in dealing with the digital world, because even I am not able to kind of make out what's a fake news, what's not a fake news. Some of it is so convincing. So what I do is that I don't forward any news to anybody. So we have to have a defensive approach. So anybody can fall into these traps. It's not just the older generation.
Thank you, sir. Thanks a lot for your inputs. We'll take two more questions. We have a question from Sharanya.
Yes. So, sir, you were talking about like bias and how algorithms originally do not contain bias, but only when we incorporate data that bias comes in. So, in this context, like especially in social contexts, and suppose like AI tools being incorporated in the justice delivery systems, if that happens, like there are certain concerns like bias. So, I mean, is it like, do you see it as a possible scenario for it to be implemented in India, because it has certain like benefits, like the pendency of cases can be possibly be solved by this, but can the biases and other concerns like this can it be addressed by AI technologies as it stands as on date?
Right. So, I mean, I can very clearly see the need for some of these technologies to be used so that we can reduce the dependency of cases and so on. But if you're going to use it for anything related to the actual judgment, then the issue of bias will be there. So currently, I don't think anybody is using it for preparation of judgments, but it is definitely being. For example, banks are using it to provide bank loans. So the applicant submits a form, and the AI engine looks at the data submitted by the applicant. Now, before this whole system is set up, when the algorithm is created brand new, the algorithm is given all the inputs from all the previous history of loan applications and the manual decision that was made for that loan application. That may run into millions of cases. So the algorithm goes through that and it notes the actual result and the data that is input, and it forms its own conclusions regarding how these things work. And when the algorithm is working today, it has already kind of primed its rules. And they're not actually rules; they are weights in a neural network, and it's impossible to find out a single weight. The whole thing is automated as one whole. Then, when a new application comes, it looks at its weights and it runs it through and then decides whether to give it to approve the loan or not. Now, if there are biases in the data, that means black people were refused loans in the past just because they are black. Then that bias gets right into the decision-making part of the algorithm. So that is the bias. Now, once it is there, it's very hard to remove it because you have to then go back to the data, remove the bias in the data, then reprime the algorithm, but that's a very, very difficult process. So I would be very cautious. There was a case when I forget what it was. It was for bail or something. There was an automated system that used AI, and then they found that system had a bias of this kind. So anything to do with justice system, and I'll be very cautious. Be very cautious not to kind of take algorithms for granted. They can be used for, say, retail or for prediction of consumer spending. Those are all fine. They don't really, even if there's a bias there, it's not a big deal. But anything sensitive, we should be very careful.
Thank you for the input, sir. So we have 2 more questions, after which we would like to wrap up. We have a question from Nitya.
Am I audible?
Yes.
A very good morning, sir, and thank you for being here first. So, sir, as you said, like you are using Linux, so I also use Linux, and I have used like Debian-based, Arch-based Linuxes. So, you can see that there are so many tools that you can use to like attack or something, and they are not regulated by anyone. So, my first question is that do you think that there is a need of cyber law, that international cyber law? And with like related to this, I have another question that these companies that you're talking about, like Twitter, Facebook, or any social media companies, they are like they used to have kind of different standard for every countries. Like for India, they are not even ready to have a nodal officer. But for Germany, they're okay. Like in Germany, there is a rule that if you're unfollowing someone on Twitter, then that Twitter will give notification to the person. Like if I'm unfollowing you, then Twitter will send you a notification that Nitya has unfollowed you or something like that. And that's like breach of privacy. But Twitter is following that in Germany. But for a nodal officer, they were not ready in India. So do you think that there is a need of international cyber law?
Right. So, first of all, before I answer the question, I must say that it is not just countries that different, big tech companies have different policies for different countries. They even have different policies for different individuals. For example, if I type a search phrase on Google and get a result, first of all, that result is fine-tuned for me. If somebody else is putting the same words, they may not get the same results. Secondly, it is what you're saying is not reality. It is Google created reality. The list of hits that you see, it is nothing. There's nothing objectively real about those results. It is a kind of organized for my what Google thinks I will find useful. It's an incredible trap. So I don't use Google at all now for search. I use DuckDuckGo. There are some cases where DuckDuckGo is not so good. So there are some easy shortcuts to ask DuckDuckGo to use Google. So sometimes I do that, but 90% of my searches are not with Google. Because the reality that we see in Google is not really real. It's the reality that is an illusion created for you. Secondly, regarding cyber laws. Now, cyber laws, unfortunately, are not really feasible at this point. The reason is that both for the governments and for the companies, there are different considerations that are completely different for different countries. What are, however, possible is called cyber norms. You can look up cyber norms. There are some interesting groups, global groups, which are proposing cyber norms. For example, how nation states should not get into cybersecurity issues. That's a norm. It's a recommendation. It's not binding. But somebody had to say it. So the cyber norms are the way to say it. But the individual laws are left to the countries themselves to kind of legislate, because they have the sovereign, only they have the sovereign right to kind of legislate over their own subjects.
Sir, what you said, like the Google reality, and that's correct, because it is showing something related what is in your cache. So whatever is in your cache, then they will set their algorithm according to that. So I was not talking about this. I was just saying that like international cyber law. I was talking about international cyber law. What USA is proposing for so long, that there should be an international cyber law that that should bind all the nations, like for some basic things. Like if there is an attack from this nation to this nation, or if there is a company working like multinational company, then that company should have kind of same set of standard for all the countries.
Yeah, so this is a little bit controversial. Now, if you look at the laws, I mean, when you say law, if you look at ICANN is a global organization. ICANN makes regulation or rules. ICANN is not a regulator really, but ICANN make rules for the use of domain names, how you can register them, how you can resolve contention when two parties apply for the same name. All this is done in ICANN. ICANN is an international organization. So that's as close to a global cyber law, but it's only for domain names. It's not for content. ICANN is not bothered about content. But beyond that, to ensure the way to do that would be, you must realize that there is a tension between the multilateral system of governance, which is the UN system, the ITU and so on, and the multi-stakeholder system, which is ICANN system. Currently, the lawmaking is left to treaties or UN-based organization. Now, the whole of the tech community are not in favor of the UN system making cyber laws for the world. There are various reasons for it, and the very reason why ICANN exists as a separate organization, as opposed to being in the UN system, is because people said, look, the UN system is good for certain things. It is not good for such a dynamic space like the internet. For example, the UN Convention on the Law of the Sea, UNCLOS, that took 20 years in the making. Now, you can't have a 20-year lawmaking process for something as dynamic as the internet. So there was this early decision from the late 90s that the internet-related, tech-related stuff should be not in the UN system, and therefore that also becomes a block for the whole to create a cyber law, because as of now, laws can only be created by that system, because only then it becomes binding. ICANN is an edge case. ICANN is not a country. ICANN has not been involved in any treaties, but ICANN is able to manage on a historical context autonomously. It is not aligned to any country now. Earlier it was US Department of Commerce, but today it is not even that. ICANN is completely autonomous and bottom up. So that is the model that we see really works. The other model for internet is perhaps a little bit inappropriate. And then you have the problem of every country agreeing for such a law. Different, like for example, China has very, very contradictory rules if you take privacy. So if you have a Chinese company which is in the US, you can't function really, because the laws are at complete conflict with each other. So it's also a bit difficult to imagine that all countries will sign up to the same laws. So I'm not a lawyer, so I can't talk anything beyond this.
Thank you, Satish, sir. We are actually running out of time. So Yogesh, can you keep it really super quick with your question?
Yeah, sure.
Thank you.
Hi, sir. It was a wonderful session, sir. So, sir, am I audible?
Yep.
Yes, yes.
Okay, so sir, I'm having my own startup company. So just like this code space solution. So it is basically a web-based technology. So the core of the company is like we create something like Squarespace or Shopify for the metaverse. So so my question is like the web is, web has evolved a lot of over the years, right? We have web 1, we have web 2, now we have moving to the web 3. So probably web 1 is a static and web 2 is dynamic. So web 3 shifting towards the a decentralized. So the everything is in internet will get into the point like readable by the machine. So is that a good upgrade in terms of data?
When you say in terms of data, what would you mean? Machines already have access to your data, but even if it is Web 3, which is a decentralized web, the systems will have access to your data because they need the data to do things for you. So what is the actual problem there? Do you think it is not a good thing for the computers or the decentralized systems to kind of manage your data? Remember that the blockchain, which is Web 3, is completely open. It is not even hidden from anybody, it's public. But the parties, the addresses are pseudo-anonymized. It's not even secure anonymization. If you want that, you have to go further beyond. But the basic blockchain kind of a thing on Bitcoin, for example, is public. So entire transaction data is public. And anybody can read it on a kind of browser. So the decentralized web usually makes everything public. But there are some very secure kind of things also. There are add-ons or specialized cryptocurrency platforms which have privacy concerns, which make it much more difficult for you to break, to identify the real person. But Bitcoin, it's been done. There have been several cases where the Bitcoin address has been tracked down to an individual person, both by security agencies and by individual users.
Yeah, since Web 1 is like information economy and Web 2 is a platform economy, so it might end up with a token economy. So the Web 3 might be end up with the token economy.
Yeah, but the problem is, you look at India. India is just passing a law against the entire cryptocurrencies. And India is a huge player in the world market. We cannot ignore India.
Yeah.
So you have a problem there. So thank you. I think we're running out of time. So thanks very much.
Yeah. Thanks a lot, sir. Thank you.
Thank you. Bye.
Thank you, Satish. Thank you for touching upon all the emerging technologies, the major ones, and then you're moving on to talking about the various challenges and also issues with respect to data, governance, security, usage, and even environment for that matter. So we're really, really happy that you were able to join in today and then enlighten our participants. So we have a couple of questions in the chat. So we really appreciate if you can take a couple of minutes and answer, because we have questions regarding, resources to study and know these domains further. So we would really appreciate if you could take
Yeah,
time out
I'll
for this.
spend for a few minutes.